Responsive. Quiet. Durable. Chrysler brakes for 1983. In this month's Master Tech training session, we will demonstrate the service procedures for the brake systems used on 1983 front-wheel drive vehicles. As you know, the diagonally split power brake system's primary hydraulic circuit activates the right front disc brake and the left rear drum brake. The secondary circuit controls the left front and right rear brakes. Although this kind of brake system has been used since the late 70s, many of its components are new and reflect significant technical advances for this year. The power brake actuation systems have been improved this year to provide more positive brake pedal feel. The aluminum tandem master cylinder has a smaller bore and longer stroke, which contributes to a higher hydraulic line pressure. The secondary piston stop pin has been eliminated for this year. In addition to the new master cylinder, a larger, more powerful dual diaphragm vacuum booster is used on some front-wheel drive vehicles. This booster provides the same brake application force with less pedal effort. Now let's see how the dual diaphragm booster works. When the brakes are not applied, the booster return spring holds the two diaphragm assemblies and the brake pedal in the released position. In this mode, equal levels of vacuum are applied to all chambers and no output force is produced. As the brake pedal is depressed, the booster's input rod and valve piston move forward, isolating the two sides of both diaphragms. Then the air intake valve opens to allow atmospheric pressure to reach the backside of both diaphragms. This pressure differential forces the diaphragm assemblies forward, pushing the output rod against the master cylinder's primary piston to create hydraulic pressure in the master cylinder. The pressure is then transmitted to the brakes. Another familiar component in the diagonally split power brake system is the pressure differential brake warning switch. Its only function is to turn on the brake warning light if there is a loss of hydraulic pressure in one half of the brake system. The two most common complaints about brake actuation systems are a spongy brake pedal or a brake pedal that goes to the floor. The first step in diagnosing the brake actuation system is to test the brake warning light. Turn the ignition key to the on position and apply the parking brake. The brake warning light should turn on to indicate that the circuit and bulb are okay. Release the parking brake so the light turns off. Next, check the brake warning light wire leading to the pressure differential switch. After testing the brake warning light, you should check the brake fluid level at the master cylinder. Wipe away any contaminants from the top of the reservoir. Remove both covers, then inspect the fluid level. If the fluid level is unusually low, it may indicate an external leak in the brake system. Next, look at the underside of each reservoir cap to make sure the cap diaphragm is not swollen. If the diaphragms were swollen, it would mean the brake system is contaminated with a petroleum-based fluid, and it would have to be repaired. Now start the engine to perform the basic hydraulic test. To do this, apply the brake slowly, then gradually increase the pedal effort while looking at the brake warning light. If the warning light turns on during moderate pedal effort and stays on when the pedal is released, the master cylinder has an internal leak, so replace it. If the light comes on at moderate to heavy pedal effort but goes out when the pedal is released, there is air in the brake system, causing a spongy pedal. To correct this condition, bleed the brake system. If the warning light turns on after holding heavy pedal effort for several seconds and stays on when the pedal is released, there is an external leak in the system. If any of these problems exist, then you'll have to repair the brake system according to the procedures in your service manual. When you receive a customer complaint that the brake pedal feels like it goes to the floor, it may be caused by a lack of adequate engine vacuum, a booster vacuum leak, or normal booster runout. After performing the basic hydraulic test, begin your booster functional test. With the engine off, pump the brake pedal at least 3 times to exhaust vacuum reserve from the booster. Then hold the pedal with approximately 25 pounds of effort. Now start the engine. The pedal should fall slightly to show that the booster is working. If the vacuum booster did not operate properly in the functional test, you'll have to check the vacuum supply hose to make sure it's not pinched, kinked, or leaking. Next, check the vacuum supply level at the booster check valve by connecting a vacuum gauge to the speed control port. Now start the engine. With the engine running at curb idle, the gauge should read normal engine vacuum. If engine vacuum levels are lower than normal, check the engine timing, the curb idle speed setting, the fast idle setting, and the AC idle up speed setting to ensure that they are within specifications. Correct as required. However, if the vacuum supply is good, but the pedal didn't fall during the functional test, the booster is defective and should be replaced. But in our case, the booster operation and the vacuum supply level are okay, so further diagnosis is required. Start the engine to build vacuum for the unapplied vacuum leak test. After building up the booster's vacuum supply, turn off the engine and wait 90 seconds. Then see if the booster still has vacuum assistance. If it does, perform the applied vacuum leak test by running the engine at curb idle while moderately holding down the brake pedal. If the engine begins to run roughly, or if there's a continuous hissing sound coming from the booster, then the vacuum booster is defective and it will have to be replaced. Several changes have occurred to the front-wheel drive disc brake system for 1983. For instance, some vehicles use the new Kelsey-Hayes single-pin caliper, while other vehicles continue to use the ATE double-pin caliper. All calipers use a phenolic piston. Combined with the pressed-in boot, it provides superior corrosion protection. Omni Horizon vehicles use the semi-metallic disc brake pad with 5 rivets and a tension outer shoe. The ATE calipers use the more conventional designed compression shoes. New on all riveted front linings is the improved gasket with a double-sided contact adhesive used for additional noise suppression. By the way, do not interchange brake components or parts, so make sure that you use the correct part numbers. And while we're on this point, 1983 brake components are not to be used to update previous brake systems. Before you begin to service the brakes, it's always a good idea to check the brake tubing for cracks, dents, or worn spots. Any abrasions, cuts, or cracks in the rubber brake hose indicate that the hose should be immediately replaced. To service the brake linings on the single sliding pin caliper, you'll have to first remove the caliper pin with a 10mm socket. After removing the pin, wedge the caliper away from the rotor, breaking the gasket adhesive seal. Then hang it from the suspension to prevent damage to the brake hose. Next, remove the outboard disc brake lining assembly, the rotor, and then the inboard lining. When any brake shoe and lining assembly is worn below 5/16 of an inch, all of the front brake pads must be replaced. But remember, use only the type of replacement pads that are designed specifically for the kind of caliper being serviced. It's very important that each anti-rattle clip be properly installed on the pad. Before you install the new disc brake shoe and lining assemblies, liberally apply Mopar multi-purpose lubricant to both adapter ways. Now remove the protective paper cover on the noise suppression gasket and carefully insert the inboard brake pad to avoid getting grease on the pad surface. Next, install the rotor on the hub. Then, slide the outboard pad on the adapter and remove the cover from its gasket. Now, inspect the caliper for any evidence of cuts or brake fluid leaks at the piston's dust boot. To service the caliper, have your assistant slowly depress the brake pedal several times to ease the piston out of the caliper bore. Be sure to keep your fingers clear of the moving piston. Be sure to prop the pedal at any position below its first inch of travel to prevent excessive brake fluid loss at the caliper. After disconnecting the brake hose at the caliper's banjo bolt, carefully mount the caliper housing in a vise. While removing the dust boot, make sure that you do not scratch or chip the surface of the boot counterbore. Use the same kind of care when you remove the old piston seal from the caliper bore. Always avoid nicking its surface. If a close inspection reveals light scratches or corrosion, the bore can usually be cleaned with a crocus cloth. When assembling the caliper, lubricate a new piston seal in clean brake fluid. Then position it in its groove and gently work the seal around until it is properly seated. Coat the new dust boot with brake fluid and install it over the piston to properly position it in its groove. Now, install the lubricated piston past its seal and bottom it against the base of the caliper bore. Properly seat the lip of the dust boot into the counterbore surrounding the piston. Using special tools, drive the dust boot into the counterbore. After cleaning the caliper fingers and piston face with a clean cloth so the gaskets will stick, carefully position the caliper over its adapter so that it straddles the rotor and both brake pads. Use caution when threading the caliper pin. Make sure it doesn't cross-thread. Then carefully torque the pin to 25 to 35 foot-pounds while firmly holding the socket squarely on the pinhead. After reconnecting the brake hose using new copper gaskets, bleed the brake system according to the procedures outlined in your service manual. The first step in servicing the self-adjusting rear brakes is to slack off the parking brake cable to allow easier removal of the drum. Further clearance can be obtained at the rear brake assembly by rotating the star wheel to back off the self-adjuster. After removing the brake drum, inspect both brake shoes to make sure that they have not been worn excessively. To replace the lining assemblies, remove the self-adjusting lever and its spring. Now rotate the self-adjusting star wheel so that each shoe expands far enough to be free from the wheel cylinder boots. Next, use a special tool to release the two hold-down springs securing the lining assemblies to the support plate. Disconnect the parking brake cable, then remove both brake shoes and lining assemblies. To replace the trailing shoe, disengage the retainer clip, securing the parking brake lever to the old trailing shoe. Then connect the old parking brake lever and its wave washer on a new replacement shoe. Now attach the upper return spring between the two lining assemblies. With the stepped forks facing outboard and the longer fork pointing rearward, install the self-adjuster. Then connect the shoe-to-shoe spring. Be sure to grease the 8 shoe contact areas on the brake support plate and anchor with Mopar multi-purpose lubricant. After expanding the self-adjuster, install the brake shoe and lining assemblies. Next, install the 2 hold-down springs to secure the lining. Then assemble the self-adjusting lever and attach its spring. After connecting the parking brake cable, pre-adjust the rear brake shoes so that they don't interfere with the installation of the drum. After properly adjusting the wheel bearings, according to the procedures outlined in your service manual, pump the brake pedal several times to partially complete the shoe adjustment. These new brakes adjust every time you stroke the pedal. After adjusting the parking brake cable, perform a road test. The self-adjusters will continue the rear brake adjustment during the test. As you've seen, the 1983 front-wheel drive brake systems are quality engineered. By using the service manual and the valuable technical service information presented in this training session, you can help maintain this quality, the quality your customers have come to expect.